In this problem, I get a binary array nums and I need to determine the longest sequence of ones in a string if I'm allowed to remove a single zero. I have to return an integer which represents the length of that sequence. So let's look at an example to better understand the idea. If nums equals 1, 1, 1, the answer will be 3 because there are no zeros. If nums equals 1, 1, 0, 1, the answer will be 3 again because I can remove the 0, giving me a sequence of 3 ones. And if nums equals 0, 1, 1, 1, 0, 1, 1, 0, 1, the expected answer is 5 because I can remove the 0 on nums of 4, which gives me a sequence of 5. The most efficient way to solve this problem is by using the sliding window technique. First, let's remember how this technique works. The sliding window algorithm is an efficient technique that allows the analysis of subsequences of fixed or variable sizes from an array or string, thus reducing the complexity of the algorithm by avoiding repeated recalculation of values for overlapping subsequences. So, I first need to initialize my variables. I start with left, 0 count, and max length, all set to 0. Left represents the beginning of the sliding window, 0 count is the counter for the number of null values in the array, and max length is the maximum length of the sequence of non-zero values in the array. Next, I declare a new variable right, which is also set to 0, and I use this variable to traverse nums. In this for loop, I start by checking if nums of right equals 0. So if the end of the window equals 0, then I increment 0 count because I found a 0. If 0 count is greater than 1, that means I have more than one 0 in the window, so I have to reduce the window from the left, meaning left is increased. In every iteration of this for loop, I need to calculate the size of the window. The size of the window also represents the number of elements between the left and right indices. I save this answer in current length. Finally, I update max length by calculating the maximum between the variable stored in max length and current length minus 1. I subtract 1 from current length in order to achieve the correct answer. If I didn't subtract 1, I would include the 0 that I must remove from the subsequence in my final answer. By subtracting 1, I take into consideration the so-called clean subsequence of ones without the 0 that I must remove. This line, in which I calculate the final value of max length, is crucial in order to achieve the final maximum length of the subsequence of ones that can be achieved by removing only one 0. This ensures that the algorithm follows the requirements of the problem and correctly calculates the final maximum length. I ultimately return max length. In conclusion, the algorithm uses the sliding window technique to find the maximum length of a substring of ones from a binary array after removing one element. By maintaining a dynamic window and counting zeros, the algorithm ensures that each element is processed only once, providing an efficient and optimal solution with O of n time complexity and O of 1 space complexity. Now, let's test this code and then submit. Remember that you can try to solve this problem in another way that might end up being more efficient than the presented algorithm.